So today we're going to be talking about solving logarithmic equations. So you can solve a logarithmic equation graphically or algebraically. If you're going to solve a logarithmic equation graphically, there's two ways that you can do this. You can graph each side pressing tab to graph two functions on the same graph. You can then hit menu, analyze, intersection, and just the x values of your intersection are going to be your answers. The other way to graph a logarithmic equation and solve is to subtract to get everything to one side so that the equation equals 0. Graph trace to find the zeros, and just the x values that cross your x-axis are going to be your answers. We'll also go over this in class since I know you don't have graphing calculators at home. So, now let's talk about solving for algebraically logarithmic functions. So, type 1, logarithmic equations with a log on both sides. So step 1 would be if the log bases are the same, set both sides equal. Ignore the log. Step 2, check for extraneous solutions. So we know that we can't have a negative number inside of our log and we can't have any zeros. So what we can do here is we just set them equal to each other because they both are raised to the same log on both sides. And we solve. Bring the 17 over. We get negative 14 is equal to 7x. Divide both sides by 7. We get x is equal to negative 2 is our final answer. We check back in our original equation and make sure that this works. This doesn't make us have a negative within our log, and neither does this. When we do 8 times negative 2 is negative 16 plus 17 is positive 1. Negative 2 plus 3 is positive 1, so it works. Now let's go on to the next one. Again, they have the same log, so we can just set them equal to each other. And solve. X squared equals 64. When we square root both sides, we have to add a plus or minus. So x is equal to plus or minus 8. Which if we put this back into our equation, both 8 and negative 8 both work because both of these squared will be positive, and it works out just fine. Type 2, logarithmic equations with a log only on one side. So step 1 is get the log part by itself. Step 2 is rewrite as an exponential function. Step 3, solve. And step 4, check for extraneous solutions. No negative numbers within the log, or 0. So for this, we can just DNA. Because it's log-dan our function right here, because as you can see that there's just one log over here and we can just start solving. DAN 4 squared equals x plus 3, which is our DNA. And now we can solve. This is 16 is equal to x plus 3. Subtract 3 to both sides. X equals 13. Put it back in, make sure it works. It does. Nothing's negative. We have our answer. And the next one. First we need to add 6 to both sides. And now we have ln of 4x is equal to 14. Now we know ln is the same thing as log base e of 4x, which is equal to 14. We can logarithmic this equals 4x because this is our DNA. And now we can solve. Divide both sides by 4. We get as our final answer x is equal to e to the 14th over 4. Now let's go on to the next. More example problems. So again, we can logarithmic both sides. So we have DAN, DNA, and we can solve. 3 to the 4th is 3, 9, 27, 81. Add 15 to both sides. We get 96 is equal to 8x. Divide both sides by 8. And x is equal to 12. Put it back in, make sure it makes an even a positive number, and it does, so we have our answer. Now let's look at the next one. We have to start off by adding 7 to both sides. Now we have log base 3 of radical negative 7x plus 1 is equal to 3. Again, we can log or dan. This is our D, N, A. Now we can start to solve. So we have 27 is equal to radical negative 7x plus 1. What we're going to have to do is square both sides. To get 729 is equal to negative 7x plus 1. We subtract 1 to both sides and get 728 is equal to negative 7x. Divide both sides by negative 7. We get x is equal to negative 104. When we put this back in, negative 104 times negative 7 is going to be a positive number. Plus 1 is a positive number, so this is all going to be a big positive number, and minus 7 is still going to be positive. So we can know that this is going to be a good answer for us. So now a mini lesson, just a recap of what we did last time. Some properties of logarithms. So the product property that we have here, we know that we can separate this to be log base b of u plus log base b of v. We know the quotient property we can separate to be log base b of u minus log base b of v. And the power property, we know we can make this n log base b of u. Now let's look at some example problems. For this one right here, it says expand as separate logs. So, we can separate this because we know when the 2 and the x to the 6 are being multiplied, which means addition. So we can separate this to be log base 5 of 2 plus log base 5 of x to the 6. But we know this exponent should come out front, so we're going to have log base 5 of 2 plus 6 log base 5 of x. And that's going to be our final answer. Now let's look at the next one. We know these are dividing, so we can separate it right away. ln of 3x to the 4th minus ln of 5. We know we can bring an exponent out front, so now we have 4 ln of 3x minus ln of 5. And we know these two are multiplying, so we need to distribute our 4 ln of 3 plus 4 ln of x minus ln of 5. And this is going to be our final answer. And the next one, condense to 1 log. This is the opposite. So first let's bring our exponents back. So ln of x to the 8th plus ln of x plus 3 squared. And this plus means these two things are multiplying together. So this is going to be ln x to the 8th times x plus 3 squared. This is going to be our final answer. And the last one. We bring our exponents back, so we have log base 3 of 7 squared minus log base 3 of x to the 5th. This minus sign means we're dividing, so this becomes log base 3 of 7 squared over x to the 5th. We know 7 squared is just 49, so we have log base 3 of 49 over x to the 5th. And that will be our final answer. Type 3, logarithmic equations with 2 logs on the same side. So step 1 is condense the equation using properties. Step 2, rewrite as an exponential function. Step 3, solve. Step 4, check for extraneous solutions. So what we're going to want to do first is we have to condense everything. So we're going to condense this to underneath 1 log to be log base 2 of x times x minus 7 equals 3. And now we can solve for this just like anything else using Logarithmic. 2 to the third equals x times x minus 7. And now we distribute and solve. So 2 to the third is 8. X squared minus 7x. Subtract 8. X squared minus 7x minus 8 is equal to 0. This factored is going to be x minus 8 times x plus 1 equals 0. And x is going to be equal to 8 and negative 1. However, negative 1 is not going to work because when we put negative 1 back in here, we get a negative underneath our log. So our only answer is x is equal to 8. Now the next one. Again, we condense it underneath one log. Log base 2 of 3 times x plus 2 is equal to log base 2 of 27. Now that we have the same log on both sides, we simply could just set what's on the inside of the logs equal to each other. So 3 times x plus 2 is equal to 27. Distribute our 3. We get 3x plus 6 equals 27. Subtract 6. 3x equals 21. Divide by 3. X is equal to 7. We check back, make sure it works, and it does. Pause this video here and try the next two on your own. This is what you should have gotten for the last two problems. Thank you for watching, and I'll see you in class.